Sorry, guys. On the last video, I was interrupted. There's only a certain amount of time I get on the screen capture video thing for the free version. So anyway, we've got an angle. You'll notice here that this angle crosses the unit circle is at about an 18-degree angle. Okay, so one of the angles is going to be 18. If I rotate it all the way around, you could guess probably what that is, right? It's 18 degrees. Now this protractor measures from the horizontal, and it's also 18 degrees, right? But it's 18 from here up this way, so it's 180 minus 18. So we're going to go hide this ruler. We've got 18 degrees, and we've got 180 minus 18, which is going to be 162. Okay, those two angles have a sine of 0.3. Okay, so let's go over here. Two solutions of the quadrants and the angles. Why do we know quadrants 1 and 2 have a sine of 0.3? Now remember when we did our all students take calculus, right? That tells you which ones are positive. All of them are positive here. All of them are, only the sine is positive there. So the sine is positive above the y-axis, right? Above the x-axis. It should make sense that everywhere above the x-axis, sine is positive. So there has to be two places where sine is positive, a positive value of the same number, right? So we're going to go ahead and approximate where this is on this little mini unit circle. Right here, this is one angle. And right here, this is our, I don't know why we're doing, makes shapes when I don't want it to make a shape. Right? Let's cancel that into shape. We got another angle over here, okay, which is this angle, okay, and we know they're in quadrants 1 and 2. We drew a quick sketch of our angles on our mini unit circle. We used our protractor and the large unit circle back from the first page to find the first quadrant solution. What was that? That was approximately 18 degrees, right? And we used the first quadrant answer in logic to find the second quadrant, which is 180 minus 18, right? So that was 162. Okay, work, I guess I could have done the work here. 180 minus 18 equals 162. Okay. Now, for part E, we're going to go to the graph of sine. Now, we're dealing with two different things here, right? We're dealing with the unit circle, which is basically the x and y values as we go around this circle, right? Any point we choose on the circle, the x and y coordinates will give us the sine and cosine, the cosine for the x and sine for the y, of any angle around this circle. But when we actually draw the graph of sine, and if I do it in degrees, I know we've been normally graphing this in radians, but we're doing it in degrees from 0 to 360. It's the same as 0 to 2 pi, right? Comes back here at pi, or 180 degrees. I can look at the graph and find where the sine is equal to 0.3. Where is the sine equal to 0.3? Now we're talking about the y value when the sine is the angle, the x is the angle, this is the angle. We're plugging into the function sine of x. So if we had an angle of x, we're trying to find the sine of the angle, y, the y value, not why, but the y value is the sine of the angle, which is x. Now, here's my x. See my angles here. These are my x values. So I'm plugging in 0 degrees, 20 degrees, 40 degrees, 60 degrees, etc., and I'm getting my graph of sine of x. Okay? The green graph is the graph of sine of x. What I want to do is find where this green graph, where this function is equal to 0.3. Now look, I've got this green graph here. Notice that from 0 to 180, you've got two places where the sine is going to be equal to 0.3. You got one right in here somewhere, right? Okay. You got one right in here somewhere, 0.3, right in there somewhere. And if you keep drawing 0.3 across, it's halfway between 0.2 and 0.4. Get one right there. Okay. Now we're going to follow that down and approximate where that is. Right. Let me draw a line from here down. And can you see that's approximately 18 degrees? And if I draw a line from here down, oops. If I draw a line from here down, you're going to see that is approximately 18 subtracted from 180, which is 162. Look at that. We're just using the graph, right? We didn't take out a calculator. We didn't do anything. What angle gives a sine of 0.3? Approximately 18 and approximately 162, right? Okay, so going back up here, again, using the sine graph, we're approximately 18 and 162, right? Now, it's not going to be perfect, right? We're approximating. They do look close to my answers from part A. I kind of knew what the answers were in part A, B, and C, right? C and D or whatever, whichever one had our answers. So we knew it was going to be approximately that, but you should be checking, right? If you got 28 here, then you did something wrong either on the graph or on the unit circle, right? Should be about the same. And this one was right before 20, so it was a pretty good approximation. Right? This is a little after 160, so it's 162 is a good approximation. Okay. Now, right? Now let's use our calculator. Okay. Be sure it's in degree mode. We're going to check our approximate answers we found by typing sine of our approximate answers. Okay. So we're going to type the sine of 18 degrees. Okay. Sine of 18 degrees in our calculator. Go to our calculator. Sine of 18 degrees, 0.309. If I were to approximate that to the nearest hundredth, that'd be 0.31. If I approximate to the nearest tenth, it is 0.3, a pretty good approximation, right? Sine of 18 is about 0.3 if I were to round to the nearest tenth, for sure. Okay. What about the sine of 162? If I plug that in, okay, sine of 162 is also the same number, 0.309 something, right? So round to the nearest tenth, 0.3. Yes, we're getting approximately the same answer. Okay, saw this in geometry a long time ago. Actually, saw this. We've seen this recently. You can use your calculator to find approximate values of sine of x is equal to 0.3. By undoing the sine function, we look for the inverse sine of both sides, right? So if we were to solve sine of x equal to 0.3, I go really hard on you guys about this. Sine of x is equal to 0.3, and I solve for x. What do you have to do to both sides? You have to do inverse sine of sine of x and inverse sine of 0.3, right? Inverse sine of x gives us x on the left, and on the right we get inverse sine of 0.3. Again, in your calculator now, inverse sine of 0.3, and it's 17.45. See, now it's not a great result because we let me make sure I'm in degree mode. I'm in degree mode. I got 17.4 degrees, right? 17.45 degrees, right? If we round to the nearest tenth, that'd be 17.5 degrees. But it went around up to 18. It would round actually down to 17. So we were pretty close, right? We approximated it to be 18 degrees, and it was 17 and a half. Okay, or if we round down to 17, pretty good. If we round to the nearest 5 decimal places, it's 17.457 60 degrees. Okay. Now, notice our calculator only gives us the one angle, right? It only gives us one angle that is equal to 17.45 something. Okay. Now, we can do the same calculation